Right, this is my second properties of water video, so this is properties of water part 2. Here are another 3 of the total 6 properties of water that we're going to talk about. Water has a high heat capacity, which means it takes a lot of energy for water to heat up, which is really, really great for organisms like this fish that live in the water. Therefore, water can be out in the sunlight, like in our oceans and lakes, and not heat up that much, and so living things can have sort of a regular temperature. It also keeps sort of coastal areas at really nice temperatures as well. Water also forms a crystalline ice structure. And this is also, we already said that all of water properties are due to the fact that water forms those hydrogen bonds with each other between the negative oxygen and the positive hydrogens, okay? And so this forces these bonds, and the way that the atoms are spaced forces some air to be trapped in between water molecules, especially when it becomes a solid. And so ice, the solid version of water, is actually less dense than liquid water. This allows ice to float on top of water, like in this picture with the polar bear here. It also creates this sort of feature, and I'm sure all of you have seen this before, where a bottle of liquid water is actually smaller than a bottle of frozen water. The same bottle, when you put it into the freezer, it will expand. Sometimes the top will come off. You usually end up having to remember to have less liquid in frozen bottles. Another property of water is that it is a universal solvent. This is a huge property of water for us. Water can dissolve lots of materials. It doesn't dissolve everything. So the term universal solvent isn't entirely accurate, but it dissolves lots of things. And water specifically will dissolve molecules that are also polar. So they also have slight positive or negative charges, or they can be ionic, which means that they have a totally positive charge or a totally negative charge. And so here is a picture of water molecules. Those are the green and brown molecules. Dissolving and attracting with these hydrogen bonds, just like it does to the other water molecules, it will form hydrogen bonds with the molecule it is attempting to dissolve. And here we get a couple of terminology things here. We have these terms that we use a lot in biology. This word called hydrophilic, which, as you can imagine, means water for hydro and liking or loving. Hydrophilic. And these are going to be molecules that like water. Hydrophilic molecules will be polar, so slightly or they'll be slightly charged, or they can also be totally charged. So, for example, salt, which was one of our examples of an ionic compound, is ionic. It's totally charged. The sodium is just a positive ion, and the chloride is a negative ion. And water will dissolve these by creating what's called a hydration shell. And that word hydration should also remind you of water, keeping hydrated. And it'll form a hydration shell around these molecules to dissolve them. And notice that the positive sodium is surrounded by the negative portions of the water molecules, because positive will be attracted to negative. Similarly, the chloride atom is being attracted to the positive parts of the water molecules. Here are some other terms that go with sort of dissolving things. We usually call the liquid in which something is being dissolved the solvent. So here water is considered sort of a universal solvent. So that's why we use that word. It is the thing in which other stuff can be dissolved in. And we call the thing being dissolved the solute. So if we go back a couple pages here, we had this blue molecule being a solute molecule, and the water is the solvent. And lastly, if we have things that are hydrophilic and they like water, we also have things that are hydrophobic. And so that literally means water fearing. If you think of phobia, arachnophobia, things like that, those are all fears. Being hydrophobic is water fearing. And if the things that were hydrophilic were polar, the things that are hydrophobic are going to be nonpolar. They have no charges at all. And so water doesn't really get along with things that it isn't literally attracted to. So things like oils and our lipids will be hydrophobic. And you will see this when you say, for example, put oil into like pasta water. You get these sort of condensed areas of oil where oil is trying to stay with itself, and then these other areas of water. You don't end up getting a mixture of oil and water where it's evenly dispersed.